Hello, my name is Jeff Lindeman with Sincerely Yours. We're a restoration and cleaning contractor that's been serving the Columbia metropolitan area since 1959. When a homeowner or a commercial property manager calls us that has recently suffered a water loss, we explain our services, which include extraction and structural drying. Often they ask about what the structural drying entails, and we've mentioned that we check the walls for any moisture content, and they usually respond that the water never got that high. Our objective here today is to demonstrate how water can wick up the wall and prove to you that the walls indeed have excessive moisture content. We're going to do a simulation of how water wicks up in your home. I'm going to show you a typical wall assembly with carpet flooring. What you have is a seal plate in the construction. Now we're not going to use a joist, but we're going to show you the typical floor construction coming up. What we're also going to have is a tack strip that's going to hold your carpet. It usually goes right about here up against the wall. Then you have your carpet padding, and your carpet gets professionally stretched over these tacks and is held in place. And then this is going to simulate the drywall. I'm just going to put another piece of wood behind here so we can hold it in the upright position, okay? This is a non-penetrating meter, and I'm going to set it to drywall. We're going to verify that this piece of drywall is in fact dry before we start. This is a non-penetrating meter, and we're checking any moisture content. As you can see, it's reading dry. Just to prove to you that this is working, it's picking up the moisture content in my hands. So this is actually very dry. I'm going to show you the same thing with a Delmore's penetrating meter. We put those pins in the drywall. As you can see, it's registering right about 10%, where it is in the green area, reading dry. So now we have our wall assembly with drywall, carpet cushion, and carpet. Now, let's just say that you're at work, your wash machine hose bursts and floods your house. What we're going to do now is add water to the carpet and cushion, which this cushion is nothing more than really very similar to a sponge. Okay, so what we're going to do is add some water to the carpet. What I'm going to do is just kind of pour it around the pan. I don't want to get it too soaked. Work this in, much like if a wash machine hose were to break and flood your house. It's not a whole lot of water. It's not standing up on the carpet, but it's flooded your house. What we're going to do is let that soak for an hour. The reason I'm selecting an hour is that typically we respond to a water damage in 1 hour. We're going to show a simulated version of how water wicks up a wall, and that water moves from wet to dry. We're going to put a little water, and let's just pretend that this paper towel is a wall. And when it touches the water, watch how it wicks up. Moves from wet to dry. Of course, this is exaggerated, but as you can see, that's what's happening with the drywall. I have two pieces of drywall. Now, by looking at it and by touching it, you can't tell which piece is wet or which is dry. The only way you can determine if drywall is in fact wet or have excessive moisture content is by using a meter or a thermal imaging camera. We're going to start with a non-penetrating moisture meter. As you can see, this piece of sheetrock is dry. This is the piece that we put into the pan for our experiment. And they were marked yesterday that this was the experimental piece. And this is how high the water has wicked up. Should start beeping right about that line. We're also going to use a penetrating moisture meter. As you can see, this piece is dry. This piece has excessive moisture content. It's pegging all the way out, going into the red. Another tool we can use is a thermal imaging camera, but a thermal imaging camera doesn't tell you if it's actually wet. It gives us differentials in temperature. If we look at a camera, the part that is wet will be darker in color compared to the surrounding surface, which should be lighter in nature because it's a warmer surface. To give you an idea how sensitive these thermal imaging cameras are, we're going to touch the wall with our hand for just a brief moment and then remove it. What you're going to see is that my hand has left the wall white due to the transfer of heat for that split second. Okay, this piece of sheetrock has been sitting on our experimental piece of carpet for just over an hour. So we're going to remove it out of the water, and now we're going to test this piece of drywall and to see if it actually got wet. The only way to verify that moisture has wicked up the drywall is by use of a meter. Let's start up top. So even though it does not appear wet, it is testing positive for excessive moisture. Now we'll use our penetrating moisture meter. I'm just going to spin it around and insert the pins. As you can see, it's going all the way over into the red. As you can see in the crosshairs on the camera, it's picking up the temperature that we're looking at. Right now it's about 75 to 76 degrees, which is cooler because of the rate of evaporation. I'm going to move it up ever so slightly to the dry portion, and notice it jumped about 79 to 80 degrees. That's a difference of 4 to 5 degrees in just a matter of an inch or two. We've demonstrated on how water wicks up a sheetrock wall. Only with the appropriate tools and meters can you confirm that a wall is either dry or wet. We're still faced with all the trapped water in the carpet cushion and carpet. If you look underneath the surface, you're going to see there's an awful lot of water, and carpet cushion is nothing more than a sponge. It's going to hold on and retain water, and what you have to do is pull all this water up through this pad and through the carpet. There's only 3 ways to remove water. That's through evaporation, dehumidification, or extraction. In our next video, we'll demonstrate the extraction method. Thank you.